Welcome to this lesson on finding and using the value of a ratio. Today we're going to talk about how to first find the value and then how to use it to answer and solve different problems. So in this case, I want you to take a look at example 1, and I want you to look at the models and pick out which model to you would represent the number of red gumballs being 5/3 the number of white gumballs. So take a second and pick one, and then we'll go over the answer. In this case, the correct answer would be B. Okay, so the number of red gumballs is 5/3 the number of white gumballs. And it makes sense because if you look at it, red is listed first, so 5, and white is listed second, so 3 on the bottom. So if you were just looking at it in terms of that, this would make sense. And we're going to talk about why that is and how that works. Right? So here we go. The duration of two films are modeled. So film A is 1, 2, 3, 4, 5 units long, and film B is 7 units long. So the ratio of film A to film B is 5 to 7. So we literally take this ratio and we turn it into a fraction. So the length of film A is 5/7 the length of film B. So visually, if you look at this, it makes sense because it's 5 out of the 7 that B is. So it's 5/7 of the length. So think of it this way. 5/7, so if I want to know A is equal to 5/7 times film B. So film B is, so A is equal to 5/7, and here B is 7 units. Mathematically, I know that to multiply this, I end up doing A is equal to 35 over 7, and A is equal to 5, which is the case. So you're taking the value of the ratio, or you're finding the value of the ratio by taking the ratio and turning it into a fraction. But now it's a little bit different when you're comparing B to A. So the length of film B is 7/5 the length of film A, because it's 7 out of the 5 that A is. So it's going to be longer. So this 7/5 is equal to more than 1, so bigger than 1. So that's why you know that this is correct, because this has to be, so film B has to be bigger than A, and A in this case represents a full film. Right? So understanding right now why the value is what it is isn't as important as being able to find it and use it. So again, the length of film B is 7/5 of film A. So again, if I wanted to find B, I could take 7/5 times whatever A is. In this case, A is 5, so let's see if it works out. And I know it turns into 5 over 1. I can cancel out 5s and I get 7 over 1, which is 7, which is the case. Right, so finding the value is actually very simple, and that's what we're going to focus on right now, because as time goes on, the value of the ratio will start to make more sense. All right, so here we go. Exercise 1. So first we're going to make a list of ratios that might be relevant to this situation, where we have the food company that produces peanut butter, and they try out a new version of the extra crunchy using twice the number of peanut chunks as normal. The company hosts a sampling of its new product at a grocery store and finds that 5 out of every 9 customers, so 5 out of every 9 customers prefer new extra crunchy version. All right, so this is a little different because it says 5 out of every 9, so this is actually a fraction for us. So we have to take that and figure out how we're going to make that into ratios. So first, let's look at the ratio of the number preferring new extra crunchy to the total number surveyed. So we know 5 prefer the extra crunchy, and 9 is, so 5 out of every 9 customers. So 9 in this case is your total, and you know that because it says 5 out of 9. So that means they surveyed 9 and 5 of them like the extra crunchy. So that first ratio that you would be able to come up with, because it's the ratio preferring the new extra crunchy, so that would be 5 to 9. Then the third one, the ratio of the number preferring regular crunchy to the total number. Well, if 5 preferred the new extra crunchy, then and there were 9 total, then we know that there were 4 that preferred the regular crunchy to 9 total. And 3, the ratio of the number preferring regular to the new crunchy. So we know that, so again, they didn't give us all this information. We had to find some of it. So the number preferring the regular crunchy was 4 to the number that preferred the extra crunchy. And the ratio of the number preferring new crunchy to regular crunchy. So the new crunchy was 5 and the regular crunchy was 4. So we're able to make a lot of different ratios here. So we're able to take the extra crunchy and compare it to total, regular crunchy, compare it to total, and compare regular to extra, and then extra to regular, because we said it does matter when the order is different. So now we're going to use the value of the ratio to make multiplicative comparisons for each of the ratios. Multiplicative comparisons are exactly what we did down here, the 5/7, and then we used multiplication to find answers. So that's what a multiplicative comparison is. It's how did I use this as in a part of a multiplication problem to find an answer. All right, so here we go. The number preferring new extra crunchy is blank of the numbers surveyed. So the first problem, the number preferring new extra crunchy, and then it's being compared to the number of people surveyed. So that's going to be this here. So that's where the new value, or where you find the value of 5/9. Okay, which makes sense because we said 5 out of every 9. So 5, the number of people preferring the new crunchy is 5/9 of the number surveyed. So what that means is if I had 45 people that I surveyed, I can take that times 5/9, and that should tell me the number of people who liked extra crunchy. Actually, I'll type it so it's a little bit easier to see. Who like extra? Okay, so that's what a multiplicative comparison is. And you have the complete sentence in your notes. I'm just taking some time, or saving us some time here by not writing the full sentence. So like I said, I could do the multiplication. I end up with 45 over 1 times 5 over 9. I can cross simplify, and 45 divided by 9 is 5. 9 divided by 9 is 1, and I get 25 over 1. So that tells me that 25 people are going, if I survey 45 people, then 25 of them are going to like the extra crunchy. Okay. Again, this is going to be a little confusing, but as time goes on, it will make more sense. The expectation is not for you to understand it 100%. The expectation is that you try it. You might stumble a little bit, but we're going to start working towards a better understanding of this as we go on. Okay, the second comparison, the number preferring regular crunchy is 4/9 of the total number surveyed, because what you're doing is you're saying, okay, well the ratio is 4/9, so then the value of that ratio is 4/9. And then what I would like you to do is I would like you to try 3 and 4 on your own, and then come back and check your answers. All right, so for 3, the number preferring regular crunchy is 4/5. The number that prefer regular crunchy. And for number 4, the number preferring new extra crunchy is 5/4. The number of new crunchy. Or, I'm sorry, regular crunchy. All right, so here's where that comes into play then. You can actually use your values to find some answers. So if the company is planning to produce 9,000 containers of peanut butter, or sorry, 90,000 containers of peanut butter, how many of these containers should be the new extra crunchy variety? and how many of these should be the regular. So in this case, we need to know that the total is going to be 90,000. So this is when you survey people and you say, okay, if I surveyed 9 total people, then I can make equivalent ratios and say, well, if I surveyed 9 total people and I multiply that by 10,000, that gives me 90,000. So I can use that simplified ratio to make an equivalent ratio to figure out how many crunchies I should make. So if there's 9 people and 5 of them like the extra crunchy, we've talked about how you can take both of them and multiply them by 10,000, and it would be 50,000 to 90,000. And that would tell a company that they should produce 50,000 containers of the new extra crunchy peanut butter. Okay, but now we're going to actually kind of turn that into a multiplicative equation here. So we have the information back here, and I know that in number 1, it compared the number that wanted new to the total. Okay, so I know that this is the value that I want to use because it's comparing new to total. And I want to know how many new crunchy varieties I should make if I'm making this many total. Right, so I know that the extra crunchy is equal to 5/9 of the total. All right, so in this case, we don't know the extra crunchy, so that's going to be our x. We know 5/9, that's going to stay. Of always tells us to multiply, and you see that in your sentence back in part B. Okay, so it says the number preferring new extra crunchy is 5/9 of. Of tells us to multiply the total, and in this case, the total we said was 90,000. So I can go ahead and I can multiply that, and this ends up being over 1. 9 and 90,000 can simplify each other, so 9 divided by 9 is 1. 90,000 divided by 9 is 10,000. So I know that x is equal to 50,000. So what that tells me is the number of extra crunchy, of the new extra crunchy variety that I should make is 50,000 containers. So if I make 90,000 containers total, according to my survey, 50,000 of them should be extra crunchy. So they should make 50,000 extra crunchy. Then I can do one of two things. I can use my value of my ratio of regular crunchy to total, which is 4/9. But if I'm going to make 90,000 total and 50,000 of them need to be the extra crunchy, well then I know I can subtract. And when I subtract, I do 90,000, so 90,000 is the total that I'm going to make. I subtract 50,000, and that tells me that there's 40,000 left, and I know that those 40,000 should all be regular crunchy. So they should make 50,000 extra crunchy and 40,000 regular crunchy. And then I could actually double check this by checking my values. So actually what I am going to do here is I'm going to get rid of this material that I have on here from other parts because you have that in your notes anyways. Alright, so here I know that the number of regular crunchy is equal to 4/9 of, and again you can see this in part B, sentence 2, the number preferring regular crunchy is, so is your equal to, actually let me show you here. If I type it out, so the number of people preferring regular crunchy is, we said 4/9 of the total number surveyed. All right, and then I'll show you here how these are replacing. So this might make a little more sense since now you can actually see the words too. Might be helpful for some of us. So the number of people preferring regular crunchy, we don't know that. That's what we're looking for. So that's our X. Is means it's going to be equal to 4/9 is a number that they've already given us. That's the value of the ratio. Of always tells us to multiply the total number surveyed. In this case, we didn't survey 90,000 people, but we surveyed 9. And so we're saying that, okay, well, we're just going to replace that 9 with 90,000 because that's how many total containers we're making. Because like we said before, when you do market research, you say, okay, we're going to take a small sample and then we're going to use equivalent ratios to determine how many things we should make. So the total number in this case is 90,000 because that's how many total containers we're going to make. And then when you do the math, again, so 9 divided by 9 is 1. 90,000 divided by 9 is 10,000. So X is equal to 40,000, which is exactly what we said up top, that 40,000 people or 40,000 containers of extra crunchy should be made. Because if we surveyed 90,000 people, 40,000 people would want regular crunchy based on our 4/9 value. Again, this can be very confusing. It's just a matter of taking time, plugging away at it. It makes more sense as you use it and as you practice it. So you do have a couple more problems here. You have D, E, and F that I actually do want you to try on your own. I want you to pick which value you should use. And I want you to set up your equation just like we've done here. And I want you to come up with your answers. Okay? I know it's going to be tough. I know that we're going to be confused, but this is where I really need you guys to stick with it and do what you think is right so that way we can build from that understanding when you guys come back to class. So as always, if you have any questions, please be sure to write them down or email me so that way we can talk about them in class.